Imagine standing beside an aircraft engine so massive that its fan is wider than the fuselage of a Boeing 737. An engine so advanced that it doesn't just push the boundaries of modern aviation, it threatens to reshape its history. This is the Rolls-Royce UltraFan, a machine that has stunned the industry and sparked a new race for the future of flight. But the real story behind this engine goes far deeper than size or spectacle. It is the result of a century of breakthroughs, failures, reinventions, and bold engineering decisions that no other manufacturer dared to attempt. With a 140-inch fan, a reduction gearbox capable of handling monumental torque, and a bypass ratio pushing the upper limits of modern turbofan engineering, UltraFan represents a turning point in aviation. But to appreciate how significant it truly is, you have to look back at the path that brought Rolls-Royce here, a journey that began in wartime skies and evolved into a legacy of innovation that spans more than a century. Rolls-Royce built its reputation during the First World War, when its Eagle engines powered British bombers and transport aircraft with unmatched reliability. A few decades later, the company created the Merlin, an engine that became a legend, driving the Spitfire and Hurricane during the Battle of Britain and altering the course of aviation history. Yet once the war ended, military demand collapsed, forcing the company to rethink its future. Rolls-Royce had no choice but to pivot toward the emerging frontier, jet propulsion. The post-war jet age wasn't an easy transition. It demanded new materials, new physics, and new ways of thinking. Still, Rolls-Royce adapted quickly, producing landmark engines like the Derwent, which powered Britain's first jet fighter, the Gloucester Meteor, and the Nenni, an engine so influential it ended up powering aircraft across both Western and Eastern blocs. These early successes paved the way for what would become Rolls-Royce's true rise in commercial aviation. By the 1960s and 70s, the company introduced one of the most daring concepts the industry had ever seen, the RB211. At the time, the biggest engineering challenge came from matching rotational speeds across fans, compressors, and turbines. Each required its own ideal speed, and even tiny mismatches reduced performance, created massive noise, and added destructive stress. Most engine makers avoided the problem by sticking with the conventional two-shaft setup. Rolls-Royce went the opposite direction. They introduced a radical three-shaft design. Instead of forcing the fan and compressors to share the same rotational constraints, each major section was given its own independent shaft. This allowed every component to run at its ideal speed, dramatically improving overall behavior while reducing noise and extending the engine's life. It was a bold move that nearly bankrupted the company, but the payoff was enormous. The three-shaft architecture became the foundation of the Trent family, engines that would go on to power aircraft like the Airbus A330, A340, Boeing 777, and the iconic A380. But the company wasn't done. Even with the Trent engines dominating much of the wide-body market, Rolls-Royce continued pushing forward. They launched the Advanced program, aimed at developing the next generation of high-performance engine technology. This effort brought in advanced manufacturing techniques, including additive layer manufacturing, which allowed the creation of extremely complex, lightweight components, and ceramic matrix composites, materials strong enough to withstand higher temperatures while reducing overall engine mass. These innovations set the stage for a major leap in performance and redefined what future Trent engines could become. All of that progress built toward one outcome: UltraFan. What immediately stands out about UltraFan is its presence. Its fan can reach an enormous 140 inches in diameter, making it one of the largest ever created for commercial aviation. Yet despite its size, the fan is incredibly light due to its carbon composite construction with titanium leading edges. This combination allows for a higher bypass ratio, an essential factor for maximizing performance and lowering noise. But the real breakthrough lies inside. UltraFan incorporates a geared turbofan system, enabling the fan and turbine to operate at different speeds through a powerful reduction gearbox. This gearbox isn't a small upgrade. It unlocks major gains by allowing the fan to spin slower and the turbine to spin faster, improving airflow and reducing stress on the engine's core. And even though it must endure enormous forces and extreme heat, The gearbox simplifies the overall architecture by reducing the number of turbine stages needed, lowering weight, and improving long-term durability. The result is an engine capable of producing around 100,000 pounds of thrust while delivering noticeably better fuel economy and significantly quieter performance than previous generations. It's not trying to beat competitors on raw power. It's aiming to outperform them where modern aviation needs it most. Operating costs, UltraFan is also built for the future. Its architecture supports 100% sustainable aviation fuel, and the engine has already undergone successful full-power validation at Rolls-Royce's advanced testing facilities. This dedication to cleaner flight signals a shift in the company's long-term strategy. Performance and environmental responsibility must now advance together. In the end, UltraFan represents far more than a single engine. It's the culmination of decades of engineering evolution, an expression of everything Rolls-Royce has learned from wartime piston engines, early jets, the RB211 gamble, the Trent dynasty, and the high-tech materials of the Advance program. And with its enormous fan, lightweight construction, and transformative geared architecture, UltraFan stands as a clear message to the aerospace world. The next era of long-haul flight will be quieter, more capable, and more sustainable, and Rolls-Royce plans to lead it. A bypass ratio of more than 15:1 means UltraFan is pushing a massive amount of air around the core rather than through it. More airflow, less fuel burn, better thrust, simple in concept, insanely difficult in practice. And here's the crazy part. UltraFan pulls this off without sacrificing durability or performance. Instead, it uses a geared system that finally lets the fan spin at its ideal speed, independent from the turbines. In older dual-spool engines, everything rotated together, forcing a compromise. Spin the fan slower for safety, or push it harder and risk structural problems. But with a gearbox, UltraFan escapes that trade-off. The result? Higher efficiency, lower stress on components, and notably quieter operation. But installing a gearbox for an engine this size? That's where things get wild. It has to survive brutal torque, scorching temperatures, and non-stop flight hours, all while being absolutely reliable. Yet Rolls-Royce made it work. The system is so effective that engineers cut turbine stages from 10 down to 6. Fewer stages mean a lighter engine, fewer stressed parts, and longer life. It's this mix of lightweight composites, refined design, and precision engineering that pushes UltraFan into a different league. And when you compare it with other big turbofans, the advantages become obvious. UltraFan tops out at around 100,000 pounds of thrust, slightly lower than the GE9X, but that's not where it wins. The real story is its gains over previous generations. Rolls-Royce claims a 25% improvement over older Trent models and strong advantages even when compared with today's largest engines. For airlines battling fuel prices and emissions targets, that's huge. It translates to lower costs, longer range, and a much smaller environmental footprint. Noise is another big win. Massive fans usually mean massive sound, especially near the blade tips. But UltraFan's geared system lets the fan rotate slower while the turbines spin faster, keeping everything in its sweet spot. Add in flexible carbon composite blades that absorb vibration, and you get a surprisingly quiet giant. For passengers and airport neighborhoods, that's a real difference you can actually hear. But here's where UltraFan really steps into the future. What it can burn. The engine is built to run on 100% sustainable aviation fuel. No modifications, no limits. Rolls-Royce already proved it in full power tests. For an engine this big, delivering this much thrust, the ability to slash life cycle emissions by up to 80% is nothing short of revolutionary. It sends a message to the entire aviation world. Large commercial jets don't have to choose between power and responsibility anymore. They can have both. And this isn't marketing talk. In Derby, engineers have pushed UltraFan to the limit in the world's largest and most sophisticated test environment, capturing enormous amounts of performance data, temperatures, vibration profiles, pressure cycles, airflow behavior, everything. The 70,000 horsepower gearbox has survived brutal stress tests, proving it can handle the forces of a next-generation geared turbofan without flinching. In other words, UltraFan isn't a fragile technology demonstrator. It's behaving like a production engine. But before it enters service, Rolls-Royce has to clear the biggest hurdle in aviation: certification. UltraFan will undergo flight tests on the legendary Boeing 747 testbed, facing the toughest safety, emissions, and noise standards in the world. If all goes to plan, certification will be complete by the late 2020s. Once that happens, airlines will be able to swap older Trent engines for UltraFan-based models, instantly gaining quieter operation, lower fuel bills, and dramatically reduced emissions. And then comes the real game changer: scalability. UltraFan isn't just one engine size, it's an entire platform. Rolls-Royce has confirmed it can be built anywhere from 25,000 to 110,000 pounds of thrust. That's enough range to cover nearly the entire commercial aviation market. Narrow bodies, mid-size wide bodies, ultra-long-haul giants, the whole spectrum. This flexibility gives Rolls-Royce something it hasn't had in decades: the ability to compete in segments currently dominated by competitors. A smaller UltraFan could target the single-aisle market it has been absent from. A larger version could go head-to-head with engines like the GE9X on future mega aircraft, whether that's a next-gen 777 successor or an A380 reimagined for a greener era. But the heart of UltraFan's value goes beyond raw performance. It's the balance, the way aerodynamics, advanced materials, and cost-saving design all intersect. A high bypass ratio, lighter fan systems, fewer turbine stages, and advanced components translate into up to 25% less fuel burn than older Trents and a significant advantage over today's largest engines. For airlines, that's millions saved per aircraft over its lifetime. Fewer moving parts and cooler running components mean simpler maintenance. And quieter operation improves the passenger experience while easing restrictions at noise-sensitive airports. This is why UltraFan feels less like another engine and more like a blueprint for the next era of aviation. It shows that cutting-edge composites, smarter aerodynamics, 3D printed components, and sustainable fuel compatibility can all work together. It proves that engineering progress and environmental responsibility don't have to be at odds. They can reinforce each other. As the aviation world prepares for a decade defined by growth, regulation, and pressure to decarbonize, UltraFan arrives at exactly the right moment. It gives airlines a realistic path to cleaner operations without sacrificing range, power, or capability. Rolls-Royce isn't just building an engine here. It's reshaping expectations for what a large turbofan should be: quiet, powerful, scalable, and ready for a future where sustainability isn't optional. With UltraFan, the next generation of aircraft won't just fly farther. They'll fly smarter, cleaner, and more efficiently than anything we've seen before.